In this video lecture, we will see this cantilever beam with uniformly varying load, SFD and BMD. So, first, draw free body diagram of this beam. Free body diagram, that means remove support. Fixed support have three reactions. One is vertical, one is horizontal, and one is movement. So movement is mx, horizontal is ax, and vertical is ay. So deflection of this beam is like this. At support A there is no deflection, at support B there is maximum deflection. So due to this hogging bending moment generates. Let's see judgmental SFD. Due to this AY direction, this is goes upward. This is straight line. And due to this uniformly varying load, there is parabolic shear force occurs. In our normal uniformly distributed load, shear force is curve inclined line, but here due to this UVL, parabolic shear force is generated. So this is like this. Positive. And movement is cubic. This is parabolic. Movement is see how movement is like this or like this. See here load is minimum, so slope is also minimum. So slope minimum, that means this is like this. This is slope. See here slope is minimum, in here slope is maximum. Slope is maximum because here load is maximum. See d square m by dx square is equal to minus w loading. So this is w and this is momental slope. If load is maximum, then slope is maximum. If load is minimum, then slope is minimum. And here shear, for shear also same terminology apply. dv by dx is equal to load. If load is 0, then slope is 0. See here, slope is 0. If load is maximum, then slope is maximum. See here, slope is maximum. Now calculate value. This is triangular load, 6 kN per meter. That means here point load of this triangular load is half 6 multiplied by 4. So 0.5 into 6 into 4 is 12 kilonewton, and act at a distance of 2 by 3. because this load acts as CG of this triangle. From B it is 1 by 3. This 2 is nothing but the 4. 4 by 3, and this is 4 by 3, 1.33. 2 by 3, 1 by 3. 2 by 3 plus 1 by 3, it's 1. So I think this is, consider this as a x. Wait a minute. Consider this as a x. This distance is x by 2x by 3, and this distance is x by 3. So it is 2 into 4, 8 by 3, and this is 4 by 3. 8 by 3 is 2.66 plus 4 by 3 is 4. Yes, correct. Now calculate this AY reaction. This AY is upward, so positive AY. This 12 kilonewton is downward, minus 12, so equal to 0. So it is 12 kilonewton. Reaction is 12 kilonewton. That means this shear is 12 kilonewton. Now calculate moment. This 12 kilonewton makes clockwise, so 12 into, and distance is 8 by 3, so it is 32. And this is mx is clockwise, so plus mx, that means this is minus 32 BMD. Unit is kilonewton meter. This SFD unit is kilonewton. So yes, it is correct. So solve it by using software also. New unit is metric, type is analytical. Create. Total length of beam is 4 meters. So node 1 is 0 and node 2 is in x direction, it is 4. So add beam. Second, give some properties. Rectangle. See, in while calculation of bending moment and shear force, we don't give some properties like width and thicknesses. But here, why we don't give properties like width and thicknesses? Because we are interested to calculate the 6 kN per meter uniformly varying load, that means live load. For that live load, we are interested to calculate SFD and BMD. We are not interested to calculate for dead load. That means width and thicknesses and etc. etc. But in StatPro, we need to provide it for errorless calculation. If we don't provide this, then StatPro shows us error and don't show SFD and BMD. So, and we are applying only live loads. So, for that live load, we are seeing only SFD BMD. So, our analysis is correct. Only this is methodology. concrete assign to view, assign, yes. Now fix support at one end, fix, add. Click on support, use cursor to assign this fix. Now loading, load case details, add. Load type is live load and title is live load. So add, close. We need only one load, live load. So in this uniformly varying load, at point A it is 0 and at point B it is 6 kN per meter. Member load linear varying, at W1 it is 0 and at W2 it is -6 in Y direction. Y direction is upward and minus sign is for our load is downward. That's why minus sign. Add, close, add, assign to view, assign, yes. So scale it for observation purpose. Scale, think linearly varying is not here. See, just analyze it and close. See our applied load is correct or not in StatPro by using SFD BMD comparison. First, I am interested to see this deflection in Y. It is at 4 meter it is 0 and at 1 meter it is 0, but in between it is shown that 0.0 y at t. StatPro shows 0 deflection. I don't know. This is y inch distance 0, 1, 2, 3, 4. This pin is 5 meter. It's 4 meters. Maximum relative displacement 4 meter length. Maximum y is 0.093. Yes, see here. Length 4 meter, maximum y is 0.093 inch. 0.093 into 25.4, that means 2.36 mm is maximum deflection at tip of this cantilever. But it is shown at 3.667 meter distance from a point. So see shear. See shape of this shear is match with our judgmental shear. So annotate beam result, shear, annotate, okay, yes, 12, 0 and in between 9. Yes, it is correct. Now see movement. See beam result, bending, maximum, midpoint, annotate. This is positive 32 in StatPro, that means hogging 32, and our is also hogging 32, so it is correct. See shape of this. See, StatPro shows us that this shape is like this. That means slope is 0 here. But why slope is 0 here? And d square m by dx square is equal to minus w. So w maximum, slope maximum. So first see dv by dx is equal to minus x, and dm by dx is equal to, dv by dx is equal to plus x, and dm by dx is equal to minus v. If so, this is wrong. If this shear is maximum here, then slope is maximum. So that's why here slope is maximum. If the shear is 0 here, then slope is 0 here. So that's why this is like this. So this shear is depend on load, and moment is depend on this shear, slope of that. See this formula. Here see shear maximum, that's why here slope is maximum. Here see shear 0, that's why here slope is 0. Slope is like this. So relation between this is this. So cantilever beam, shear force diagram and bending moment diagram. This beam is similar to previous beam, only here see at point A, at fixed point, this 6 kN per meter is maximum, and at tip of cantilever at B there is 0. So see, first remove support and draw free body diagram. Fixed support have 3 reactions. One is AY, other is AX, and another is EMX. So here goes upward. Here see, W is maximum slope, shear slope is maximum here. So that's why like this. And at point B load is 0, so shear slope is 0. Slope, that means this. See this. Slope is maximum here, and here slope is 0, because dv by dx is equal to w. If load maximum, slope maximum. If load 0, slope 0. Now this beam deflect like this. That means hogging bending moment generate. So here this goes downward. At A there is fixed support, that means reaction comes, and here see dm by dx is equal to minus v. That means if v is maximum, slope is maximum. V is maximum here, so slope is also maximum there. So that's why this is like this. And at tip of P, shear is 0, so here also moment slope is 0. See this, moment slope is 0 here, and here moment slope is maximum. Now calculate AY reaction. Convert this UVL into point load. For that, formula is triangle area half, base is 4 meter and height is 6 meter, so it is 12 kilonewton. And this distance is 4/3. So here moment is positive 12 into 4/3, it is 16 and plus mx, that's why this is minus 16. And here ay is positive upward ay minus 12, that means ay is reaction is positive 12, that's why here 12 kilonewton and this moment is 16 kilonewton meter. So see this in TAT software also. This is our previously solved example. Let's copy this and paste at x, so z is equal to 5 meter. You have made a change to the structure. Okay. So loading I edit there, like at A it is maximum. Here see, this is minus 60. Now toggle this load for this beam and take another UVL 0 6 linearly varying 0 minus 6 direction y. So select beam, assign to selected beam, assign select. So load is similar. Now analysis, this run analysis. See this selected beam at point A there is maximum load. So that's why this deflection is minimum here at point tip, and here this selected beam at this cantilever tip end there is maximum load. Now see shear difference. Value is at fixed end, it is same 12 kilonewton. See our 12 kilonewton and shape like this. This is like this. U load also. So this shear force is for at fixed end A there is maximum load, like this triangle, like this, and this shear force is for at point at fixed point there is minimum load, that means zero load. See, load maximum, slope maximum, load minimum, slope minimum. Here load maximum, slope maximum, load minimum, slope minimum, and shear force. See this bending moment is bending moment is same, because see at fixed end, both at fixed end shear is maximum. Shear is maximum at one location, same location, that's why bending moment is same. But we change our load, that's why this SFD is change here. See, movement is directly half. See, this is minus 16, this is 16, and this is 32. So loading position is impact on movement directly, double or half, and also it impact on shear slope. Thank you very much.